that are commonly confused and used, we use them almost interchangeably, meaning we use them the same way as if they all meant the same thing, but they don't all mean the same thing, that have to do with heat, are heat, temperature, and thermal energy. Okay, so these three words are actually really different. And after you're done watching this, you also might want to check out page 259 in the textbook because it has something similar. Okay, but what I want to do first is let's talk about what is heat. What is heat? You have your definition sheet in front of you. Okay, so this is.
That was my research.
Transfer. I'm trying to learn something.
All right, so heat is a transfer of thermal energy.
What? That's not right.
Okay, so
It's too good to
no,
be true.
this is how I'm going to remember it.
Oh,
Okay, heat is a transfer of thermal energy. All right, so now the question is, what is thermal energy?
It's the total energy of particles that make up a
Substance.
Okay, so this is the total energy of the particles that make up a substance. All right, so we know that heat is a transfer of thermal energy, and thermal energy is the total energy of the particles that make up a substance. What's temperature?
is a measure of the kinetic energy.
Okay, good. It's the measure of it's the measure of the average kinetic energy of the particles in a substance. Okay, so let's go with temperature first now because I think that this one is the one that will be the easiest for you guys to remember. How do we measure temperature? What are the different units? Celsius. Okay, remember that that's going to be degrees Celsius.
Fahrenheit.
All right, degrees Fahrenheit. And Kelvin. Does Kelvin get a degree symbol? No. Okay, actually I'm going to rewrite these again so that I can write out the whole names next to them for you. But if you just want the symbols, that's fine. And then Kelvin. Let's mislink these.
I don't even know how this is.
Okay.
Look, see?
We're recording this. Please thank you for being quiet. Okay. So temperature can be measured in Celsius, Fahrenheit, and in Kelvin. All right. Does it matter if temperature is the measure of the average kinetic energy of the particles in a substance? Do you think it matters how much of the substance you have to find out its temperature?
Yes.
When you put a thermometer in water, does it matter if you have a tiny bit of water or a lot of water?
No.
It matters how hot or cold it is.
Okay, but remember, is there such thing as cold?
No.
No.
Unless
It just matters how hot or something is. So in fact, for temperature, it does not matter how much of the substance you have. All right? It doesn't matter because if it's the average, it's going to take the average for the whole thing. Okay? It's going to take the average for the whole thing. It doesn't matter how much it has. All right. So then let's think about energy. What unit do we use to measure energy? Who remembers this from maybe 6th or 7th grade? What unit do we use to measure energy?
Watts.
Nope, watts is for power, but you're close. The units for energy are, they start with a J.
Jolie.
Jules.
Joules.
Jolie.
Well, it's spelled like Jolie. See? Jolie.
Joules. It's joules. Alright, so we're pronouncing it like jewels, like jewelry.
What?
So thermal energy is measured in joules. Now, if thermal energy is the total energy of the particles that make up a substance, does it matter
Yes.
how much of the substance you have to find out if it has a lot of thermal energy?
Oh, this has been a really fast
Yes,
block.
because it's the total energy. So if you have an ice cube and an ice sculpture, and both of them are 0 degrees Celsius. Okay, I have an ice sculpture, maybe I have an ice swan, and then I have an ice cube. Okay, which one is going to have more thermal energy?
Wow.
The swan, because there's more of it, right? The more particles you have, the more energy it can have. So the bigger something is, if you're finding thermal energy, the more it's going to win. So what if I light a match? Okay, I have one little match and I have a whole fancy ice sculpture. This time it's of a pine tree. All right? I don't know why you do that, but if you had one. Which one has more thermal energy? The nice big pine tree ice sculpture or the tiny little match?
The ice sculpture.
The ice sculpture, there's much more of it. There's much more of it. Okay, so the ice sculpture is going to win. It's going to have more thermal energy. Now, let's talk about your idea though. So if I have a pot of soup, okay, or a bowl of soup and a spoonful of soup, which one has the most thermal energy?
Pot.
The pot, right? Because it has the most of it, okay? But which one is going to have the highest temperature? Can I tell by looking which one's going to have the highest temperature?
Yeah.
No, I can't
No.
tell by looking. What would I have to use? What tool would I have to use to find the temperature?
A thermometer.
A thermometer. Okay, good. All right, so now let's go back up to heat. Because now that we've talked about temperature and thermal energy, heat is the transfer of thermal energy from one thing to another. Okay, so what can we measure? What can we measure heat in? Any ideas? What do you think? I'll give you a hint. If it's going to be a transfer of thermal energy, it's probably going to be measured similarly to thermal energy. Joules. Okay, this one will also be measured in joules. And just sometimes, like when it comes to food or other things like that, it can also be measured in calories. Okay? You don't have to worry about that. That's just good information to have, that it can also be measured in calories. But for our class, it's going to be measured in joules with a capital J as the symbol for joules. All right, so if it's about the heat, if you transfer of thermal energy, okay, it goes from one thing to another thing, all right, do you think it matters how much of the substance that you have in this case? It's a transfer of thermal energy. Do you think it matters how much of something that you have? You don't think so?
Yes.
Okay. Does anybody disagree with Michael?
What was the question?
Okay, so
Yes.
some of you think that it matters, okay, and some of you think that it doesn't matter. Okay, so let's take an example. If I take a can of soda, okay, and the can of soda is warm. Right, let's say I had it in the garage in the summer, okay, and I want to cool it off. Okay, if I put 2 ice cubes next to it, okay, and those ice cubes are going to steal heat right out of the can, okay, and that's going to bring the temperature down inside the can. Will the transfer be greater with just a few ice cubes, or if I take that can and put it in a full cooler of ice?
Full cooler.
Full cooler. So does the amount matter?
Yes.
Yes. Okay, the amount matters here. So what's the only one where the amount of the substance
knew it.
doesn't matter? Temperature.
Temperature.
Okay. All right, Kyle, we're done.
Okay.